Lesson: Key stages of AI model development. Developing an AI model is a complex and multifaceted process that involves several critical stages, each requiring careful consideration and precise execution. The key stages of AI model development can be broadly categorized into problem definition, data collection and preparation, model selection, training, evaluation, deployment, and maintenance. Understanding and mastering these stages are essential for professionals seeking to excel as certified AI workflow and automation specialists. The first and arguably the most crucial step in AI model development is problem definition. A well-defined problem sets the foundation for the entire project, guiding the choice of data, model, and evaluation metrics. It involves understanding the business or operational need, identifying the desired outcome, and framing the problem in a way that is amenable to an AI solution. For instance, if the goal is to reduce customer churn, the problem might be framed as a classification task where the model predicts whether a customer is likely to leave based on historical data. The importance of this stage is underscored by the fact that a poorly defined problem can lead to irrelevant data collection and inappropriate model selection, wasting valuable resources. Once the problem is clearly defined, the next step is data collection and preparation. This stage involves gathering relevant data, which can be sourced internally or externally, and ensuring it is clean, well-structured, and representative of the problem at hand. Data cleaning involves handling missing values, removing duplicates, and correcting inconsistencies, while data transformation might include normalization or scaling to ensure compatibility with the chosen model. Practical tools such as Python's Pandas library and data cleaning frameworks like OpenRefine can be instrumental in this process, providing efficient means to manipulate and clean data. The quality of data directly impacts the model's performance, as illustrated by a 2019 study by IBM, which found that data scientists spend up to 80% of their time on data preparation, highlighting its critical role in AI projects. Following data preparation, the focus shifts to model selection. This stage involves choosing the appropriate algorithm or set of algorithms that are best suited to solve the defined problem. The choice depends on several factors, including the nature of the data, the type of problem, and the desired performance metrics. For instance, decision trees might be suitable for a straightforward classification task, while deep learning models could be more appropriate for complex image recognition challenges. Frameworks like scikit-learn and TensorFlow provide comprehensive libraries of pre-built models and algorithms, facilitating the experimentation and selection process. These tools allow practitioners to rapidly prototype and evaluate different models, optimizing them to meet specific performance criteria. Model training is the stage where the selected model learns from the prepared data. During training, the model iteratively adjusts its parameters to minimize the error between its predictions and the actual outcomes. This process is governed by optimization algorithms like gradient descent, which guide the model towards better performance. Training deep learning models often requires significant computational resources, and cloud platforms such as Google Cloud's AI platform offer scalable infrastructure to support this need. Practical considerations during training include avoiding overfitting, which occurs when a model learns the training data too well and performs poorly on unseen data. Techniques like cross-validation and regularization are commonly employed to mitigate this risk, ensuring that the model generalizes well to new data. Once a model is trained, it must be rigorously evaluated to ensure its effectiveness and reliability. Evaluation involves testing the model on a separate dataset, known as the validation or test set, to assess its performance using predefined metrics such as accuracy, precision, recall, or F1 score. These metrics provide insights into the model's strengths and weaknesses, guiding further refinement if necessary. In real-world applications, it is crucial to consider the specific business context when interpreting these metrics. For example, in a medical diagnosis application, a high recall may be prioritized over precision to minimize the risk of missing a positive case. Tools like scikit-learn offer built-in functions to calculate and visualize these metrics, aiding in the comprehensive evaluation of model performance. After evaluation, the model is ready for deployment, where it is integrated into the operational environment to provide real-time predictions or insights. Deployment can be challenging, requiring considerations of scalability, latency, and integration with existing systems. Containerization technologies like Docker and orchestration platforms such as Kubernetes are invaluable in this stage, allowing models to be packaged with their dependencies and deployed consistently across different environments. An example of successful deployment is Netflix's recommendation system, which leverages sophisticated machine learning models to deliver personalized content suggestions, enhancing user engagement and satisfaction. The final stage in AI model development is maintenance, which involves monitoring the model's performance over time and making necessary adjustments to ensure it continues to deliver accurate and relevant predictions. Models can degrade in performance due to changes in the underlying data distribution, a phenomenon known as concept drift. Continuous monitoring systems, such as those provided by Amazon's SageMaker, can detect such drifts and trigger retraining or model updates to maintain performance. Regular maintenance ensures that the model remains aligned with the evolving business needs and data landscape, providing sustained value. In conclusion, the development of an AI model is a comprehensive process involving multiple stages, each with specific challenges and requirements. By understanding and effectively navigating these stages, from problem definition to maintenance, AI professionals can develop robust models that provide actionable insights and drive business value. Practical tools and frameworks such as scikit-learn, TensorFlow, Docker, and cloud platforms play a pivotal role in streamlining this process, offering scalable and efficient solutions to common challenges. As AI continues to evolve, the ability to adeptly manage these stages will be a critical skill for any certified AI workflow and automation specialist, ensuring they remain at the forefront of technological innovation.